exercise 7 from our Mind Action series, chapter 6. So just to quickly, briefly recap that exponential law that this is all based on. Okay, so the law states that anything to the power of, let's say, a to the power of n, which is then to the power of m, results in the product of the powers. Right, the product of the powers allow us then to have a shortcut for something that could have been written as x times x times x, which now means x to the power of 1 times x to the power of 1 times x to the power of 1 becomes x to the power of 3. How did that happen? It's the same as saying x to the power of 3. If that x carries a power of 1, this is the base, this is the power, I'm multiplying, then I get x to the power of 3. So what my answers would be here is then x bracket, close the bracket, to the power of 2 becomes x squared. Number 5, x to the power of 2 times x to the power of 2 multiplied by the 4 gives me x to the power of 2 times 4, which is power of 8. Okay, then I see these here with my negatives. Right, let me first just clarify. We need to go back to our rules with signs. We said that when we have a negative value to the power of an even value, the answer is always positive. Example for that would be minus 2 to the power of 4 is a positive, not 8. Okay, this is 2 times 2 times 2 times another 2 would be a positive 16. The other one is when we have a negative something to the power of an odd value, our answer would be negative. Let's give an example of that. Minus 2 to the power of 3. Minus 2 times minus 2 times minus 2 gives me an odd number of minuses, which then results in a negative 8. The connection here is negative value to the power of an even number cancels all the negatives, leaving you with a positive, but negative value to the power of that odd value, that odd number will always result in a remaining negative. So I'm never going to be able to cancel negatives with odd powers. So let's get back to Mind Action Series number 9. And I see here that this is a negative x to the power of an even value, which means I don't need to stress now about figuring out minus x times minus x times minus x 6 times. I can simply use my rule. It's going to be a positive x to the power of 6. Right. Now let's look at this one here, number 13. A little bit more happening in my bracket. I have a base, right, and I have a base here as well, right? So this is x carrying the power of 4, but what I have is also a negative 2 carrying a power of 1, okay? And that power of 3 will influence that negative 2 base to the power of 1 becomes negative 2 to the power of 3. And what I have here is I have x to the power of 4 times 3 with this one right here. So we don't actually write it like this. This is just breaking it up, separating them so that you can see clearly. But what I do now is this is a shortcut. This right here is a shortcut for saying negative 2 x to the power of 4 times negative 2 x to the power of 4 times negative 2 x to the power of 4. 1, 2, 3. that results in negative 2x to the power of 4 to the power of 3. I have reduced writing it out not once, twice, and 3 times to only once, but to the power of 3. And when I simplify now, I simply apply the rule. Looking at a negative value to the power of an odd becomes a negative 8 in this case, because it's 2 to the power of 3. The same result as if I were to say in minus 2 times minus 2 is a positive 4, times another minus 2 is a negative 8. Back to my bracket, x to the power of 4 times the power of 3, x to the power of 12. And that's what I've explained here by doing that. So we must always look at the negative and the nature of its power. And there is my x to the power of 12 because I've applied my exponential rule with the product of the powers. Okay, so hopefully that clarifies simplifying when we have brackets and powers and apply this rule in exercise 7. So basically what I have here is what was discussed in our previous video when we did simplifying of exercise 8, and we focused once again on the laws for our signs, but also what I introduced was this little summary right here. To be aware of our sign, our coefficient, our variable, and exponent. So what I'm going to do is I'm just going to cut and paste this little summary here, and I'm going to put it right here where our new work is, because this is something that you will use for the rest of your algebraic life, which means till the end of matric. And you will be able to always work very carefully when you are aware of your summary. Your summary is your checklist, okay? Your checklist to make sure that you are applying everything correctly, okay? Whenever we multiply, whenever we check variables and exponents, we have 2 or 3 terms, this little checklist comes in very handy. For now, we will focus on our fractions. Algebraic fractions are simply fractions that we've seen before. 6 over 3 is an improper, or 2 over 5 is a common fraction. But now we're combining it with a bit of variables. And as soon as we throw variables into the mix, we start working with algebraic fractions. So let me look at number P. Our focus now will be this law, where, as I mentioned in term 1, always look where your higher power is. The higher power for your base that you're working with will show you where the basis will remain. Okay, so let's just put that down there. Highest power, highest value of the power is where your base will remain. But let's just add something that confuses us sometimes, the idea of dividing A by A. It becomes 1. Why does this happen? Where did this originate from? It originates from our law. A to the power of 1 divided by A to the power of 1 means A to the power of 1 minus 1, which gives me A to the power of 0, which becomes 1. Therefore, any value divided by itself becomes 1. Any variable divided by itself to the power of 1 becomes 1. Should I have exactly the same powers, I get exactly the same answer. So let's just remember we are allowed to divide variables with each other because we're allowed to subtract the powers. So let's look at number P. Okay, this is from exercise, I think it's 7 or 8. I think it's from exercise 8 with a division. So let's just look at how we are going to cancel. We are allowed to cancel when we have one term. Cancel meaning simplifying. So minus 16, a to the power of 12, b to the power of 2 over 12, a to the power of 8, b to the power of 7. And I see I'm going to indicate simplifying like this. I first look at my sign. Here we go. I first look at my sign. My sign says a negative divided by a positive. The rule is a negative divided by a positive becomes a negative. I write my negative down and I draw my line. My line is there to remind me I might have something left in the denominator. I might have something left in the numerator. I cannot get rid of it. It doesn't become naught because naught divided by anything is naught, and anything divided by naught becomes undefined. So I need to be very, very careful about that. Right.